Suddenly, alarms blared. Computers threatened to overload. Astronauts faced a mission abort just minutes before the Eagle touched down. But a woman, back on Earth, already knew what to do. How did one programmer's foresight prevent total disaster on live television? The 1960s were a crucible of technological ambition. The Cold War stoked a space race. President Kennedy declared the United States would land a man on the moon by decade's end. NASA, a young agency, had no choice but to attempt the impossible. Engineers strained against slide rules. Mathematicians computed by hand. Software engineering was decades away from formal recognition. Programs emerged as afterthoughts, often cobbled together at the last minute. Conventional wisdom held that hardware was king, software a mere support. The Apollo program would soon demonstrate the fallacy of that belief, thanks to the work of one brilliant and determined woman. Margaret Hamilton faced a seemingly impossible challenge. Apollo's guidance computer had to process data in real time. Picture this: a spacecraft hurtling towards the moon, bombarded with information. Every calculation, every adjustment, held the key to life or death. Hamilton pioneered asynchronous execution that allowed the computer to handle multiple tasks concurrently. Her work ensured that the Apollo guidance computer could respond instantly to the ever-changing conditions of space. Her innovation laid the groundwork for real-time computing systems found in everything from aircraft to medical devices. Even at MIT, Hamilton encountered sexism. Hamilton started at MIT as a weather girl, turning the equations of meteorology into code. She was self-taught. Programming was so new, no textbooks existed. She and her female colleagues were often relegated to testing other programmers' code, becoming experts at finding bugs and writing reliable software. They were, in effect, the unsung heroes of early software development. These women became the unexpected nucleus of NASA's Apollo software team, the Good Old Girl Network. Hamilton insisted on testing the system to its breaking point. Margaret understood that astronauts wouldn't always do things perfectly. So, she intentionally tried to crash the system repeatedly. She simulated errors, pushed limits, and induced failures. She wanted the software to be robust, even idiot-proof. This approach, revolutionary at the time, made Apollo's software far more reliable than anyone expected. Weeks before launch, disaster struck during a simulation. An astronaut accidentally selected the pre-launch program mid-flight. This immediately began erasing crucial navigational data. Panic gripped the team. Hamilton quickly intervened, designing code to prevent such errors from affecting the real mission. Her solution, implemented just in time, proved invaluable when similar errors threatened Apollo 8 and Apollo 11. Years later, the Apollo code remained critical. After the success of Apollo, NASA wanted to discard the source code. Hamilton fought vehemently against letting it disappear. The code held invaluable knowledge. It represented countless hours of work and ingenuity. She eventually prevailed. The Apollo code became a reference point for future generations of software engineers. Hamilton coined the term software engineering. Programming was then seen as a dark art. Hamilton believed in a rigorous, methodical approach, elevating the discipline. She formalized the process, introducing concepts like modular design and error handling. Her work transformed programming from a craft into a legitimate engineering discipline. The Eagle was minutes from landing on the moon when alarms blared. The Apollo guidance computer was overloaded. Too many tasks were running simultaneously. The computer threatened to crash, potentially forcing an abort. Hamilton, watching from mission control, recognized the problem immediately. The computer was running low-priority tasks when it should have focused on landing. Thanks to her priority display design, astronauts Neil Armstrong and Buzz Aldrin could see which tasks were essential and override the non-essential ones. The priority display allowed them to regain control and land successfully. The Apollo 11 moon landing captivated the world. It was a triumph of human ingenuity and courage. Though Hamilton's contributions remained largely in the background, her code was essential to the mission's success. She later founded her own software companies, continuing to push the boundaries of what was possible. Today, software governs nearly every facet of our lives.